Dear students, our next topic is periodicity of the properties. As we discussed earlier, elements having similar valence shell electronic configuration have been placed in the same group. Chemical properties depend on the valence shell electronic configuration and possesses the similar chemical reactions and chemical characteristics. Therefore, elements show gradation in the physical property in the same group. Here we are discussing variation in some of the physical properties of elements in a group and across a period. Before we are starting the properties of their trends in the periodic table, few basic things you have to keep in your mind. Number 1, elements are arranged in the periodic table in order of increasing atomic number. Number 2, in the same period, more electrons are added up in the same shell. In the group, number of shells are increasing. So let's start with the first property, that is shielding effect. First of all, we define it. The reduction in the force of attraction between the nucleus and the valence electrons present in the inner subshell is called shielding effect. So when we are moving from top to bottom in a group, the shielding effect increases. Why it increases? Because when we are moving in a group, the number of the valence shell and the number of the electronic shell increasing. So the number of electrons in the inner subshells increases, which cause to increase the shielding effect. As you move from left to right across a period, the number of the electron in the inner subshell remains the constant. So that's why shielding effect remains constant. For example, sodium having more shielding effect than lithium. Our next property is atomic size. The size of an atom is the average distance between the nucleus of an atom and the outer electronic shell or the valence shell. So student, when you are moving down the group, the atomic size increases because more shells are added in it. And when you are moving across the period from left to right, what happened there? Because more electrons are added in the same valence shell and no addition of any extra valence shell, and force of attraction in between the nucleus and the valence shell increases. Therefore, atomic size decreases. When we are moving across the period, the electronic atomic size is decreases. Refer the pictorial representation of atomic size trends on your screen for your better understanding. Our next property is ionization energy. Students, you know that atom is always neutral. When electrons remove or added up, then it is converted into an ion. So here we are defining our next property, that is ionization energy. Ionization energy is defined as the minimum amount of energy required to move the outermost electron from isolated gaseous atom. Unit of ionization energy is kilojoule per mole. Ionization energy is in actual a measure of the extent to which nucleus attract the outermost electron. Now we are discussing its trends. In the group from top to bottom, our ionization energy decreases. Why? Because the shielding effect increases, which leads to weaker attraction of the nucleus for the valence electron, so easier to remove it. That's why ionization energy decreases when we are moving in a group from top to bottom. Across a period, when we are moving from left to right, our ionization energy increases. Shielding effect remains constant and nuclear charge increases. When more and more electrons are added, the force of attraction will increase. That leads to difficult to remove the valence shell. So ionization energy increases when we are moving from left to right. As the color scale clearly represents the trend of ionization energy in the periodic table on your screen.